Welcome to our webinar about one planning baseline. So it will be about data and planning, my two favorite topics. Maybe before we dive into it, so if you have followed webinars of Solventure before, you can always collaborate, participate in discussions through our Mentimeter. So feel free to already scan this code with your phone or open it in your browser on your laptop, so you can participate. So my name is Tom Vorselmans. I'm a product manager at Solventure. So as I said, my favorite topics are data and planning, and that's what we will talk about today. So it would be nice if we could go to the Mentimeter to our first question. That's actually an open question, like what triggered you to join this webinar? Are you having challenges with data? Are you thinking about implementing a planning system, a financial one, or more in supply chain context? So, all right, so about the pitfalls. Okay, so supply chain project, unreliable data, yes. Okay, definitely I will cover that. Just another point of view. Okay, cool. So business performance. Okay, nice. Okay. So you don't have to close the Mentimeter yet, so there will be some other questions during the session. And so I will talk about three topics. So maybe for many of you, the link between supply chain and finance isn't that clear, but I believe there is as a link, especially on data level. So I will talk about that. And then we'll talk about data lakes. Should you do it or shouldn't you do it? So in the last 2-3 years, I've been having a lot of discussions about that topic. And the last topic is about data quality. So that's what you can expect from the session. So let's go. So the first question on the Mentimeter. We'll go to the. So if I ask you the question, so are there in your company activities where finance and supply chain are doing similar things, or where they have shared activities? What would you think about for those two teams? Do you see certain similarities? Inventory management, yes, okay. Forecasting, all right. Both focused on working capital, okay. Okay, interesting one. So indeed, safety stocks, yeah. Supplier selection, entering, forecasting. Yeah, so here on the screen, you see a little bit the overview of where Solventure is working on. And today focuses, of course, on the data side. So you see here the baseline, the bridge between execution and where you have the operations, your ERP system typically, maybe if you're in logistics, a WMS, if it's more in operations, a MES system. And we believe that making that data available for planning, both supply chain, which is then S&OP, the tactical level, but it can also be the more operational planning, where you go with MPS on weekly or daily buckets, or with scheduling, where you will plan on production line level in continuous time. So that's the planning aspect, but also financial planning, where it's more about valorization of the forecast, budgeting, and that's where we believe it's relevant to work with one baseline, especially for sales and supply chain. Where I was thinking about that, so the shared activities, one major one is forecasting. So supply chain team is often doing forecasts with focus on volumes, as they need to make sure that the right volumes are produced and made available in warehouses. And finance is also focusing on forecasting, but then to valorize it, translating into budget, cash flow projections. Another thing where there are commonalities is reporting. Supply chain, they're having a lot of KPIs that they're monitoring, while they're also interesting for finance. So, of course, in finance, there are other focuses, like more focus on, for example, a cost to serve, while supply chain is focusing on inventory turnover. Both teams are often also involved in working capital, supply chain maybe more in the inventory part, to optimize that. So to have as low inventory as possible through setting safety stocks, thinking about service level targets. And finance, and they're also monitoring inventory turns or slow moving stock. Another example can be supplier contracts, where finance is involved in setting those contracts, and supply chain making sure that those contracts are executed as good as possible, so we avoid penalties. Those are typical shared activities. And what we see in practice often is this, that both teams are working in parallel, and both teams are getting data from the ERP systems. The demand and supply planners are working in an APS system, collaborating with sales on having, for example, a good forecast and getting information from the market. And the financial teams doing the same, the controllers, for example, working then with an FP&A system. And we see them often work in parallel. If we translate that to the example of forecast, so both teams work on a volume forecast, supply chain keeping the focus on the volumes. Sometimes we see also a translation to value, typically then based on an average cost. And financial teams also doing that, but then in a slightly different way. And there we see then having that two forecasts are in the open in the company, and then what is now the truth. And that's actually what we would like to do differently. So there we see our data orchestration layer as the central place to exchange data with the ERP systems, and that's both supply chain and finance consume from that layer to get data. Translating that to the example of forecast, then supply chain still has focus on the volume forecast, but it makes it available for the financial teams as input, and these teams can then focus on translating into value. And in that way, there's one truth, one central forecast. Of course, that requires having an intermediate layer, that common data model for planning, and that's where we are typically working on. And so we get data from the ERP systems, we can get the volume forecast from the planning system, and we can make the value forecast also available. What we often see is that that the volume forecast also needs to be uploaded into ERP systems, for example. A typical use case can be an ATP check available to promise, where a check is done before entering a sales order. Can we actually do this given the forecast that's already in the system? Those are common use cases where these three systems need to work together and exchange data. Sometimes we also see that not all data is available in the ERP systems. And that's why you see here also planning data management. Certain parameters are very specific for planning. To give an example, changeover matrices, they're not very relevant for an ERP system or to support processes there. So often we also need to find a place then to store that data. So when talking about this model here, the common data model for planning, that's a little bit a link with data lakes. So when I have discussions with companies, then we often have discussion like, yes, we're planning to build a data lake, or we're working on it, and that's actually the second topic. What to data lake or not to data lake? That's the question. Should you do it? Are you doing it? And that's actually my next question in the Mentimeter. So the first question is there. Yeah. Do you have a data lake in your company? Are you planning one, or is your IT team building it already? Let's start with it. Planned, used, okay, nice. Right, most people, more IT teams are thinking about it or are already doing it. So that confirms it a little bit. Yeah. Okay. And for the ones that are doing it or using it, do you see there are certain challenges, or was it a walk in the park to set that up, or was it a complex endeavor? The different definitions of the same product, yeah. Same info from different angles with input, okay. Okay, interesting. And so I also agree that with those examples. I think the challenge, if you want to build an enterprise data lake, you need to involve a lot of teams in your company, and it can become a really big project. Also, when you make certain choices, you often start with the use case. So I often see that it's getting started with a reporting use case, like reporting on revenues or as sales reports. And then as certain designs are made, and then suddenly it's like, we're now going to implement a planning system. We will extend it during the project, and then but that definition is not exactly the same. You're going to need different viewpoints from different teams, and so that's one of the challenges, that you need to involve a lot of people, and it can become a very big project. The other three topics, I'll zoom in on that a little bit more. So alignment on definitions, that was also mentioned. data granularity, that you need data on different levels for different use cases, and the frequency of integration. Talking about alignment on definition, so to give a concrete example of one of our customers, a watch producer, and so they talk about a certain watch, but then if you talk more to the people that really produce it, they start then asking questions, yeah, which model do you actually use? Because apparently behind a watch you see in the catalog, there are many models and evolutions across time, and there is always, of course, an initial design, but maybe they improved that design to make it, for example, better for more water resistant, or they took some action after some support feedback that one of the components in the watch breaks down too fast, and that they need to improve that component. And so depending on who you talk to, the concept of the watch is not always that easy. And if you want, and if you need to bring that into account, for all departments, it can cause a lot of complex discussions about what is a product in which context. Another example, so we were also very active in food and beverage industry. So products can be linked to different variants. It can be about certain labels on the packaging. It can be about that for one market there is 4 cookies in a pack, and in another market you have 8 cookies in a pack. It can be about temporary packaging, where there is a new recipe and they want to bring that very clear on the packaging, maybe for during a promotion or during a certain period of the year. It can also be about private label or branded, that actually what is in the package is the same, but that it's then private, having a different packaging towards the market. And so also again, depending on who you ask, the definition is different. Another topic that can cause a lot of discussion is what is a location. So if you talk about, for example, planning, it's often we have production facilities. Okay, that sounds straightforward. Let's bring those locations in our data model. But then there are a lot of complexities that can come up. You might have an external DC that's very close to your production facility, and for maybe you want to count that as part of it, or maybe have an external manufacturer that is really linked to one facility. I also have seen examples where there is a specific duty-free area that is customs controlled, and not all products can enter there. If you start talking about one facility, there might be different areas. Also, it's very important to make that distinction, like a DC versus a work-in-progress store, where the products are there for production. There might be different logistics areas. Even buildings can be important. So depending on, again, if it's about production, if it's about planning, if it's about different departments, you can get very different answers on what is a location. Another topic is the data granularity. So a typical question we need to answer in the planning is what is available inventory. And also there, you can have a lot of different answers and perspectives. It can be like, it's a location based. Per plant we have an inventory, but maybe it can also be relevant to have inventory on batch level. For example, if it's about certain shelf life calculations, then you need to know which batches are there, or lots, if it's a combination of batches. Another angle can be about available and certain statuses, like maybe certain inventories on a quality inspection or blocked. Scheduling processes might require very detailed inventory on certain storage units like silos or tanks, because maybe this production line is only fed by a certain silo, and then you need to go on a very detailed level. Or it can also be about, okay, certain inventory reserved for customers or even for specific sales orders. And so if you need to bring all the possible discussions into account and to think about that company-wide, for example, loading an inventory table, which sounds like an easy topic, can become very complex. And the last topic is about frequency. So here you see the three typical ways to bring data into a data lake. You can think about the batch orientation, where it's a daily synchronization. If you go then to multiple times, it's called a near real time. And then we talk about every 15 minutes or every hour to get the data in, or really real time. And then it's more a streaming approach where the changes constantly come in and get processed. So the more you go up in this list, the more complex it is. And of course, that means also the more costly it is. And of course, if you want to build a data lake that can be used also to support real-time needs, you often end up in a complex setup that is quite has quite a big cost. While at the other hand, if you link that to planning, so for S&OP and finance, often a daily update is okay. Even planners don't always like it to see updates popping up while they're making their plan. So often it's even desired to have a stable data set to work with on the planning. If you go to the more execution planning, like scheduling, then there are typically some objects where near real-time integration is relevant to get an update on, okay, is the plan actually being executed as we planned it? For example, production orders or inventory updates you might want to get those more frequent. And actually, this is if you would ask ChatGPT or Google about data lake architectures, you often end up seeing visuals about the medallion architecture with a bronze layer, a silver layer, and a gold layer. So it perfectly makes sense to use a data lake to collect all your raw data in there in a bronze layer. And then this is actually where we just talked about it. So building this global common data model, that is quite complex to make that happen for your whole company. And then you have typically a gold area where you prepare the data for different consumers. As you see here, for example, planning, more the operational side, or sales, etc. And that's actually a little bit the question: is it really realistic to build such a global data model? And that's actually our perspective of Solventure. And so we recommend to look at it from a pragmatic way. Use your data lake to collect your raw data, and then build business-oriented data marts with a focused group of consumers. And this is where Solventure is specialized in, that planning data mart area, within the consumers, supply chain team with an APS, a finance team with an FP&A tool, and corporate performance management, which is actually using a lot of the same data as the other two. And so here you see an example of one of our food and beverage customers, where we realized such a data mart, sourcing it from many ERP systems. It's a global company with many subsystems, with also custom systems. And we brought that all together in one planning data mart. And that was then the source for, in this case, Arkiva as a planning system. Another example in the pharma industry, one of our customers, where they have two SAP systems, one oriented on more the finance side, invoicing, all the financial flows. Also, that system is then the master to create master data, like products and customers. And in the other SAP system, they focus on production. They also have a data warehouse available with all the sales history. And their big customers deliver their forecast through flat files, which is, and those four are then consolidated, integrated in a planning data mart as input for the planning system, in this case also Arkiva. And the last topic, so it's not only about getting the data flowing into a data lake, of course, it's also about making sure that the right data is there. And also within Solventure, we created a lot of focus on that because we saw that for a planning project, whether it's financial planning or a supply chain, an APS planning system, the data quality and the data availability is a key to success to make it work. Because if you want to automate things, you need to have good data. And we look typically at this from these dimensions. So, and what do they mean? So completeness is about do you have all the data? That's the most evident one. Are all the fields filled in that you need for a certain process? Consistency, it's about linking data sets. Can we link all the data sets together? To give an example, if you have sales history, we typically have a reference to the product and to the customer. Can we find all the customers in the sales history? Can we find all the items in the sales history? Uniqueness is about doubles, avoiding that you have the same data multiple times. Detecting that is very important, of course, especially in a setup where you have multiple sources, like the reference case I just showed of that food and beverage customer. The same product might exist in all those systems. We need to make sure that that is brought together. Timeliness, it's about how up-to-date is your data. For example, if we count on inventory being up-to-date until the end of the last business day, we can also try to measure that, so we are and detect that if certain data is outdated. Validity, it's about the formatting and the data values. And a good example there is the status of certain objects, like an item status. There we might expect it's an active item, or it's a phasing in item, or it's a deprecated item. So often we expect certain statuses because in planning there is business logic linked to those statuses. For example, we will only forecast for the active ones. And accuracy, and that's the hardest one to measure. That's if data represents reality. So is actually what you see in the data in line with the actual situation in real life. To give an example, maybe the item status is active, but maybe we haven't sold that product anymore in the last 2 years. Is it then still active, is then the question. So that's about the different dimensions. And that's what I wanted to show you now today. So within Solventure, we have a product or data quality monitor, which is actually which we use in our projects to make a measurement of the data quality during the project, but also after go live to make sure that we keep monitoring it, because data is always living, and master data is always created, new SKUs are added, new customers are added. So it's important to keep the quality high. So it's about measuring evolution. And what is also very important is measuring in linked to the planning processes. So, and having it in your data model for planning, and then zooming in on that. So what we can do is zooming in on a specific process, and then you see all the data objects linked to that process, the quality of each data object, and then it's possible to zoom in on the rules where we have issues, and then drill down to specific cases where the data is wrong. So here we look at the rule that checks in the sales history, can we find all the items? And there are about 3,000 of the rows where we cannot find it. It's possible to monitor the data quality and to zoom in on specific problems. So also linking it to the dimension that I just mentioned, giving certain issues are more important than others, and in that way we can keep track on the challenges with data and to make sure we evolve in a positive way towards a go live of a planning system. Okay. So if that last topic about data quality triggered you, so I wanted to do a call to action. So if you're interested, or if you're thinking about implementing a planning system, an APS or an FP&A tool, so and you're wondering, is my data of my company ready actually for such a system? So we could support you by doing a health assessment, and we did that already a few times for customers, to see where are you with your data, or there are certain actions needed before we can actually successfully roll that out. Don't hesitate to contact us. So with this, scan this QR code and contact us, so we can show we can talk about it and see if we can do such an assessment for you. Typically 6 weeks, we can go from reading your data, analyzing it, and coming to some first insights, and define with you a potential action plan to see what is needed to improve the data quality in your company. If there are questions asked, feel free to do so. Does your system take real-time sensor data from MES, from the shop floor management system? If there is a use case, of course it's possible, but for planning, that is often not required. In most cases, we connect to the MES systems in a scheduling context to exchange on the data of the production orders, whether the production orders are executed as planned. Okay. So thank you for joining, and see you later.